Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is November 2019, paper 4, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Welcome along to another past paper walkthrough. Today we're going to be going through the OCR November 2019 paper 4, which is a higher tier calculator paper. Let's get started. Question 1. Carol makes birthday cards. Each card takes the same amount of time to make. She makes 3 cards in 48 minutes. She has an order for 80 cards. Can she complete this order in 3 days if she works 8 hours each day? Show how you decide. Okay, so I think what we need to do here is to work out how much time it's going to take to create all 80 cards and compare that with the amount of time that she has available. Okay, so up here we know that she can create 3 cards in 48 minutes. So from that we should be able to work out how long it takes to make 1 card. So if 3 cards are in 48 minutes, then 1 card equals 48 divided by 3, which is 16, isn't it? 16 minutes per card. Okay. Okay, and we know she has orders for 80 cards. So the time to make 80 cards, then what's that? That's going to be time for all cards is going to be her 80 cards multiplied by the 16 minutes it takes to make 1 card, then, isn't it? What's that? Now, according to my calculator, 80 times 16, that's 1,280 minutes. Okay, and what's that in hours? I think if we divide it by 60, we should get that in hours, shouldn't we? Which is 21 and 3 recurring, which is 21 and a third, isn't it? What's that in hours and minutes then? You can actually just use this button here to convert it into hours and minutes. I don't know if you knew that, but that's 21 hours and 20 minutes then. Okay, so 21 hours 20 minutes. Okay. And then, what do we need to do now? So she can complete this order in 3 days if she works 8 hours a day, or can she complete it? So we've got 3 days, 8 hours a day. So time available. That is going to be 3 lots of 8 hours then, isn't it? 8, 16, 24. Appears she has plenty of time. Is that it? Seems to be. No catch. She has plenty of time. So yes, she can, as 24 hours is greater than 21 hours 20 minutes. Question 2. Use the formula f equals s divided by the root of t times m to find the value of f when s is equal to 5.8 times 10 to the 5, t is 4.1 times 10 to the 8, and m is 3.7 times 10 to the minus 2. Give your answer in standard form, correct to 2 significant figures. Okay, this looks fairly horrendous. Okay, let's just sub it all in and find what we've got. So the form we've been given is f equals s over root tm. So subbing in what we know, what do we know? We know s is 5.8 times 10 to the 6. And we're going to be dividing that by the root of t times m. Well, t is 4.1 times 10 to the 8. And multiplying that through by m, which is 3.7 times 10 to the times 10 to the minus 2, and that's all being square rooted, isn't it? Okay. Now this is the calculator paper. I mean, you can, you know, multiply mantissa and mantissa and exponent with exponent and try and cancel it all down. I'm just tempted to type it all very carefully into the calculator, just as it is. And I think I should be able to do that if I'm careful with how I key it in. Okay, so I'm going to use the fraction button first off, so I can really closely follow that layout that I've been given. On the numerator part, I've got 5.8 times 10 to the 6, and there's actually an exponent key down here, times 10 to the x. So I'm going to use that one, and then type in the power 6. Okay. Then on the bottom row, I need to square root everything. So it's going to be the root of, and then 4.1 times 10 to the 8. And I'm going to multiply that by 3.7 times 10 to the negative 2. Okay, now you should just note that the square root symbol goes all the way across, doesn't it, to the whole other side of my calculation. So it's looking pretty similar to what I've got on the page. I'm fairly confident this will come out right. Apparently that is 1489.13888881. Okay, well we need to round it off to 2 significant figures, and we need to give it in standard form. Okay, so to two significant figures first off. I'm going to round, the first significant figure is that 1, which is 1,000. The second significant figure is the 4, which is in the hundreds. So that means we need to round this off to the nearest 100. So that number rounded off to the nearest 100 is nearer 1,500 than 1,400, isn't it? So it's going to be 1,500, but that isn't in standard form, is it? Put that in standard form. That's going to be 1.5 times 10 to the what? Thousands is 10 to the 3, isn't it? 10 to the 3. 1.5 times 10 to the 3. Question 3. At a railway station, trains are either eastbound or westbound. An eastbound train leaves the station every 25 minutes. A westbound train leaves the station every 45 minutes. An eastbound train and a westbound train both leave the station at 8 AM. When is the next time that the two trains leave the station together? Okay, now actually this is you might not notice, but actually a lowest common multiple problem. We've got these two trains leaving the station at 8, so they're both going off at the same time. Basically what we need to do is find the lowest common multiple of 25 and 45 to see when they're going to leave the station at the same time again. Okay, now the different ways of finding LCM, I suspect on this particular one it's just going to be easiest to list all the multiples of 25 and 45 until we find the same one for both. So that's how I'm going to do it anyway. 25, 50, 75, 100, 125, 150. Don't know how far I'm going to have to go. 175, 200, 225. Okay, that will do for now. Let me just switch to the other one. 45, 90, 135, 180 is that? And then 225. Oh, that was a good guess. had a feeling that I was getting close. Okay, so there's my common multiple of those two numbers. It's 225. Okay, so that's 225 minutes, isn't it? Now to convert that into hours and minutes, all I need to do is divide 225 by 60. So 225 divided by 60 is equal to 225 divided by 60. That's 3.75 as a decimal. So that's 3.75 hours. Now again, I can just use this magic key here to convert that into hours and minutes. So that's 3 hours and 45 minutes. See, that's a super handy key. I've used it twice already. So 3 hours and 45 minutes. So from 8 o'clock, so what's 8 a.m. plus 3 hours and 45 minutes? That's going to take me up to 8 plus 3 is 11. Plus 45, it's going to give me 11:45, isn't it? Okay, so that is the time that they're next going to be in the station together. 11:45 a.m. Good job. Question 4. Bob makes dry concrete by mixing cement, sand and stone in the ratio of 1 to 2 to 3 by weight. He buys the cement, sand and stone in bags as shown in this table. So cement is 25 kg and costs £5.50, sand is 20 kg, costs £2, and stone is 15 kg and costs £3.90. He packs the dry concrete into 30 kg bags. Bob buys just enough cement, sand and stone to make 50 bags of dry concrete. Show that Bob buys 500 kilograms of sand. This is quite a lot of info that we need to get through here, isn't it, to get to an answer? Where to start? Well, we've got the ratio of concrete here. It's cement, sand and stone in the ratio of 1 to 2 to 3, isn't it? Okay, so that's going to tell us how many kilograms of each of those things we're going to need in order to make our concrete. Okay, so how much concrete do we need? We want 50 bags of concrete, and each bag of concrete weighs 30 kilograms. So how much concrete is that altogether? So concrete required is equal to 30 times 50. Now with these sorts of questions, it's really easy just to have like a whole page worth of calculations all over the page if you're not careful. And it's really difficult then for the examiner to go and unpick it all and make sure that they award you all the marks. Now what I tend to do is I always kind of show or state what it is I'm finding. Now you don't have to write an essay, but a couple of well-chosen words at the front here, just explaining what it is you're doing, will make your work much more easy to follow for the examiner, and also for you when you come through and check your work a bit later on. Okay, so just get into the habit of kind of stating what it is you're doing for each calculation. It will add wonders to your method. So what's 30 times 50? Reaching for the calculator. 30 times 50, that is 1500. So we want 1500 kilograms of concrete. Okay, that's good. Now, we know the ratio of cement, sand and stone that goes into that concrete. So now we can divide our total amount of concrete into that ratio. So we're going to divide 1500 into ratio 1 to 2 to 3. That's what we're planning to do, isn't it? So how do we do that? Well, we add all the ratios together. 1 plus 2 plus 3 is 6 parts, isn't it? Okay, then we're going to divide our 1500 kilograms into 6 parts. So 1500 divided by 6, and that will tell you how much each part is worth then. So 1500 divided by 6, that comes out to be 250. So 250 for each of those parts then, isn't it? So that means we can take the ratio of 1 to 2 to 3 and we can scale it up then by a factor of 250. So that means we need, so the first one, remember, was cement, and then it was sand, and then it was stone, which annoyingly is the same initial as sand, but anyway. So one lot of 250 is 250, two lots of 250, that's 500, and three lots of 250, that is 750. Okay, so that means we need 250 kilograms of cement, 500 kilograms of sand, and 750 kilograms of stone. Okay, so we've kind of done what we needed to do then, haven't we? So sand is this one here, it's 500. So I can just say, therefore, we require 500 kg of sand. Part B says Bob sells the 50 bags of dry concrete for a total of £396. Calculate Bob's percentage profit. Well, his profit is going to be his income, which is going to be the £396, minus his expenditure, how much he spent on buying the stuff to start with. Okay, so we know his income already, it's 396, but we don't know the outgoings yet because we haven't calculated it. So that's the first job we need to do. Now, if you remember from the first part of the question, we worked out that we required 250 kg of cement, we needed 500 kg of sand, and we needed 750 kg of stone. Okay, so from that we can work out how many bags we needed for each of these then. So 250, so if you remember, cement comes in 25 kg bags. So if we need 250 kg, then 25 divided by, 250 divided by 25 is going to be 10 bags, then, isn't it? So we're going to need to multiply £5.50 by 10. For 500 kilograms of sand, if it comes in 20 kilogram bags, how much is that then? That's 5 bags is 100, so 500 would be 25 bags. So we need 25 of those. And 750 kilograms of stone in 15 kilogram bags. So how many times does 15 go into 75? 15, 30, 45, 60, 75 goes in 5 times. So I think that's 50 bags then, isn't it? Times 50. You can just use a calculator if you're not sure how I did those. So then we're going to multiply those together then to work out how much is the cost of each of these things. Cement, that is going to be £5.50 times 10, which is, well, it's just £55, isn't it? Sand, that's going to be £2 times 225, so that's going to be £50. And stone, that's going to be £3.90 times 50. Well, times 100 would be 39, wouldn't it? 300, no, it would be 390. And then half of that for 50, half of 390. Ugh, maths. 200, 195, 195. Okay, so that costs 195. Adding all that up, I suppose I could just do this on a calculator, but I try and do things in my head when I can. 105 and 195, that costs 300 altogether, doesn't it? Okay, so what's his profit? So profit is going to be income minus expenditure, which is going to be his £396 he had coming in, what he sold it for, and the £300 that he sent. That is a profit of £96. But remember, we need it as a percentage. Now you can find percentage profit by taking his profit and dividing it by his expenditure, and then turning that into a percentage. So that's going to be 96 over 300, which I believe 96 divided by 300, that comes out to be 0.32 as a decimal. and that as a percentage is going to be 32%. Another way of thinking about it is income divided by expenditure, and then subtract 100. That's another way of doing it. But anyway, the answer is 32%. Question 5, multiply out and simplify this quadratic. I've got 4x plus y multiplied by x minus 3y. Now, just have to remember to multiply everything with everything, or use two eyebrows, a nose and a mouth. So 4x times x, that's going to give me 4x squared. 4x times minus 3y, that's going to give me minus 12xy. Y times x is just positive xy. Just flipped it around so it's alphabetical. And then finally, positive y times minus 3y is going to be negative 3y squared. Okay? Now notice I've got two terms in xy in the middle, so I can collect those two together. That's going to give me 4x squared minus 12xy plus xy, that's minus 11xy then, isn't it, in the middle? Minus 3y squared. And that's my final answer. 4x squared minus 11xy minus 3y squared. Cool. Question 6. A bag of sweets contains only mints, sherbets and toffees. The ratio of number of mints to sherbets is 2 to 3. The ratio of number of sherbets to toffees is 7 to 5. What fraction of the sweets are sherbets? So we've been given two different ratios here, and I think what we need to try and do is trying to bring those two ratios together and kind of squish them together and make one big ratio. Okay? So what we really want then is a ratio of mints to sherbets to toffees. That's what we want, isn't it? And then we can compare all three. Now we've been given the ratio of mints to sherbets of 2 to 3. So that means I can write those under here. Look. So the ratio of mints to sherbets is 2 to 3. And we also know that the ratio of sherbets to toffee is 7 to 5. So I can write that under the sherbets and toffees column. So 7 sherbets for every 5 toffees. Okay? Now what we want to do is we want to try and kind of get a number in every space. Okay? And the way we can do that is we can have a look at this column in the middle here where we've got both numbers and try and find a common multiple of those two numbers. So what does 3 and 7 both go into? They both go into 21, don't they? 3 times 7 is 21. So if we can scale up the first part of this this ratio by multiplying it by 7, so 3 times 7 gives me the 21, and the 2 times 7, that's going to give me 14, isn't it? So 14 to 21. So 2 to 3 is equivalent to 14 to 21. And doing the same with the other one, 7 goes into 21 3 times. So if we scale up that second ratio by multiplying through by 3, 7 to 5 becomes 21 to 15. And then the two parts of the ratio kind of fit together then, don't they? I've got 21 in the middle. So for every 21 sherbets, I get 14 mints and I get 15 toffees. So I can piece it all together. So now I know the ratio of mints to sherbets to toffees. I can now work out what fraction of the sweets are sherbets. So I've got 14 to 21 to 15 is my overall ratio. So there's 14 parts are mints, 21 parts are sherbets, 15 parts are toffee. So 14 plus 21 plus 15. How many parts is that altogether then? 21 and 15 is 36 plus 14, 40, 50, isn't it? There are 50 altogether. So therefore the fraction of sherbets then is going to be that 21 sherbets out of the 50 we have in total. Okay? Doesn't ask us to cancel it down. I'm just going to leave it like that. 21 over 50. Question 7. 12 students take 2 tests. Each test is out of 60. The scatter diagram shows the results for 10 students. Okay, so we've got 10 out of the 12 students already plotted on the scatter graph, and the first part of the question gives us the 2 extra students that we need to plot. Okay, so you can treat these as coordinates. So the 11th student that we need to add on got 36 in test 1 and 44 in test 2. So that's all we need to do is find 36 along test 1. So what we've got here, we've got like 10 little squares between 0 and 10, so each square is worth 1. Nice and easy scale. So 36 is going to be here, and then 44, same scale on the other axes. It's going to be there. Okay, so I've plotted the 36 and the 44. Next one, 38 and 41. 38, 41. It's going to be there. Now, part B wants us to describe the type of correlation we have here. This is nice and straightforward. Look, we've got a clear upward trend going on here. If I was going to draw a line of best fit on, it would look something like that, which is definitely sloping upwards, isn't it? So this, I would say, is strong positive correlation. It's positive because the line is sloping upwards from left to right, and it's positive, strong because the points are all pretty close to that line. Okay, we haven't got any massive outliers or anything, so I'm going to say that this is strong positive correlation. Okay, strong positive correlation. Now the last part says draw a line of best fit, which I kind of already did, and it says another student was absent for test 2 and the student scored 40 marks on test 1. Use your line of best fit to estimate a result for the student on test 2. Now that's really easy to do once you've got your line of best fit drawn. All you've got to do is read up from the value that you've been given. So I think we've been told they got 40 marks on test 1. So reading up from 40 on test 1 until we hit our line of best fit. Okay, when we hit line of best fit, we change direction. And go the opposite way. You can see that comes out here on my graph, which is about 43. Okay, so that's what I'm going to estimate then. I'm going to estimate that as 43 marks. Part D says work out the percentage of the 12 students whose result on test 1 is lower than their result on test 2. So they did worse on test 1 than they did on test 2. Okay, now coming back to the graph. If I draw on a line on here that shows when they did exactly the same, so if they did exactly the same, then they're going to lie on this diagonal line then, aren't they? That goes through 0, 0, 10, 10, 20, 20, 30, 30, 40, 40, and so on. So this line, if I do a kind of a diagonal line, dotted line up here, this line here represents them doing equally well. So if they're above this line, they're going to do better on test 2 than they did on test 1. And if they're below this line, they're going to do better on test 1 than on test 2. So we want the points that lie above the line then. So how many are there? Let's just go through and ring them. There's that one, 1. There's that one, 2. There's that one we draw, 3. That one other one we drew, 4. And that one there, 5. So actually there's 5 of them altogether that lie above that diagonal line. Okay? Out of 12, so we want to work out what 5 out of 12 is as a percentage. So I'm going to write down 5 students did better on test 2. So they're the 5 we want. So 5 over 12 is a percentage. All we've got to do to turn that into percentage is divide it. 5 divided by 12. And as a decimal, that is 41, well, 0.416 reoccurring, isn't it? Which is 41.7 rounded off. So that is 0.417, which is equal to 41.7% to 3 significant figures because I rounded it off. So my answer is 41.7. Question 8. The diagram shows the price paid by 2 groups of people visiting the fun fair. And we can see the amount that they've been paid, but part of the ticket on both has been obscured. They've been greyed out, so we can't see the actual values there. But we've been given the number of adults and children for both, and we've been given the total for both. Now it says, assume each adult pays the same price and each child pays the same price. Find the price for an adult and the price of a child. Now this is actually just a simultaneous equations question. We can set up our simultaneous equation like so. Looking at the first card, 5 adults and 4 children sums to £78. So I can just write 5a plus 4c equals 78. That's going to be my equation 1. And then the second ticket, 3 adults and 6 children cost 63. That's going to give me my second simultaneous equation. 3a plus 6c is equal to 63. So that's going to be equation 2. Now in order to solve these, you need to try and get the same number on both. Okay? Either for a or for c, and then you either subtract or add them together to get rid of one of your variables. It's called solving by elimination. So I can either try and get the a's the same by multiplying the first one by 3 and the second one by 5. I think I'm gonna try and get the c's the same. And I can do that by multiplying through this one by 2 and this one by 3. That will give me 12c for both. So let's take the equation 1 and multiply it through by 3. 5a times 3 is 15a. 4c times 3 is 12c. 78 times 3, 7, 14, 20, 210, and 3 eighths, 8, 16, 24. It's 234, isn't it? 2, 3, 4. And then doing the same for equation 2. 3a times 2 is 6a. 6c times 2, 12c. And 63 times 2, that's 126. Now hopefully you can see now that my 12c and my 12c are the same. So if I subtract these from each other, then those are going to cancel each other out then, aren't they? Going to leave me with nothing. And 15a take away 6a, that's going to leave me with 9a. 12c take away 12c is zip. And then 234 take away 126. What's that? 4 take away 6 is 8. 2 carry away, take away 2 is 0. 108 then, isn't it? So 9a is 108. So then what's a? 108 divided by 9. 9 is going to 108. 9, 18. It goes in 12 times, isn't it? So a is going to be equal to 12. Okay? So we know a is 12 now. So we know that there are 12 adults. Oh, sorry, the price of an adult ticket was £12. We still need to work out the price of a child ticket. We can do that by substituting back into our original equation. So substitute a equals 12 into either 1 or 2, doesn't really matter. Let's just put it into equation 1. Okay, so if a is 12, then 5a is 5 lots of 12. That's 60. 60 plus 4c is equal to 78. Taking 60 from both sides, that will give me 4c is equal to 18. And then dividing both sides by 4 gives me c is equal to 4.5. £4.50 then, isn't it? Okay, so what is the price? How much is the adult and the price for a child? So then the adult ticket is £12 and the child ticket is £4.50. Bargain. Question 9. Here's a function. Function A. The input, we subtract 4 from it, and then we multiply it by 3 and we get the output. And number k is input into function A. The output is also k. Find the value of k. So if k goes in and k comes out, then if I take k and feed it into this function machine, first off I'm going to be subtracting 4 from it, so I'm going to get k minus 4 in the middle there. And then I'm going to multiply it by 3, aren't I? So I'm going to get 3 lots of k minus 4. And we're told that is all equal to k, because the output is the k as well. So that's going to be equal to k. Okay, so that is the formula we get. So we get 3 lots of k minus 4 equals k. Okay, now removing the brackets, that gives me 3k minus 12 is equal to k. Subtract k from both sides. That's going to leave me with 2k is equal to 0. And then, sorry, 2k minus 12 is equal to 0. And then I'm going to add 12 to both sides. So that's going to give me 2k is equal to 12. So k is equal to 6. K is 6. Right, part B says the output of function A is y. Write an algebraic expression in terms of y for the input of function A. Well, let's say the input is x. Then we know that when we feed that through the function machine, we're going to get 3 lots of x minus 4. And that is going to be equal to, y. Okay? So what we need to do here is kind of change the subject, really, make x the subject. So move everything over to the other side. So first off, dividing through by 3, get rid of that 3 on both sides. That's going to leave me with y over 3 is equal to x minus 4. Then adding 4 to both sides. Plus 4 plus 4. That's going to give me x is equal to y over 3 plus 4. Okay, so x is y over 3 plus 4. Write an algebraic expression in terms of y for the input of function A. Well, that's it then. Y over 3 plus 4. So my algebraic expression in terms of y for the input would be y over 3 plus 4. Okay, now you can just double check that by feeding that through the machine. If I get y over 3 plus 4 and I take away 4, it's going to leave me y over 3, and if I multiply it through by 3, I'm just going to get y back. So I'm pretty happy that that works. Okay, part C says the diagram shows a composite function with an input n and an output of 96. So n goes in, we apply function A, and then we apply function A again, and we get 96. Find the value of n. Okay, so if I take n and I feed it through the function machine once, I'm going to subtract 4 from it and then multiply it by 3. So that's what I get there, isn't it? 3 lots of n minus 4. Now if I take 3 lots of n minus 4 and I feed it through the function machine again, my 3n minus 4, I'm going to be subtracting 4 from it, and then I'm going to multiply it all by 3 again, then, aren't I? And then that is going to be equal to 96. Okay? So now we need to work backwards and find n. So dividing both sides by 3 first off. So divide by 3, divide by 3. 3 is into 96. What's that? That's going to cancel with that. 96 divided by 3, that is equal to 32, isn't it? So that's going to give me 3 lots of n minus 4 minus 4, and that's equal to 32. Okay, then add in 4 to both sides. That's going to give me 3 lots of n minus 4 is equal to 36. Now what? Okay, now again, dividing through by 3 to get rid of that other 3. That's going to give me n minus 4 is equal to 12. And then adding 4 to both sides. Going to get n is equal to 16. Okay, n is 16. The value of a house, h, is given by the formula h is equal to 165,000 times 1.03 raised to the power of t, where t is the number of years after the 1st of January 2010. Write down the value of the house on the 1st of January 2010. Okay, well, when on that date, the number of years is going to be 0, isn't it? So what we're going to get is 165,000 times by 1.03 to the power 0. Now, anything to the power 0 is 1, isn't it? So I'm just going to get 165,000 on the 1st of January. Okay. What is the annual percentage increase of the house? Well, I'm multiplying through by 1.03 each time. Okay, so that is 103%. So that means the increase, annual percentage increase, is going to be 3%. Show that the value of the house is over 200,000 on 1st of January 2017. Well, that will be 7 years later. So here, t is equal to 7. So what we're working out, h, that is going to be 165,000 multiplied by 1.03 to the power of 7. Now, I cannot do that in my head, so I'm going to reach for the calculator. 165,000 times by 1.03 raised to the power of 7. That comes out to be 202,929. So I'm just going to write that down. Equals 202,929. Okay, so show that the house, yes, which is 202,929 is bigger than 200,000. So we've shown it, haven't we? Question 11. Are these two triangles definitely congruent? Give a reason. Now we can see that they look pretty similar and they've got exactly the same angles. We've got 36 and 36, and I've got 80 and I've got 80 and I've got 64 and 64. So they certainly look pretty darn alike. But can I definitely say that they're congruent? Well, we've got several tests for congruence that we know about for triangles, and they have fancy names. One is side, side, side. One is side, angle, side. One is angle, side, angle. And one is RHS. So they're the 4 different tests for congruency that we need to know for GCSE. Now, is this any of these? No, it is not. This is given as angle, angle, angle. Got 3 angles that are the same. That is not one of our tests for congruency. At best, we can say that these two triangles are similar, mathematically similar, because all their angles are equal. Okay, so are these two triangles definitely congruent? No. A is not a condition for congruency. Okay. Right, and then part B says prove that these two triangles are congruent. Okay. Well, here, much easier. I've got an angle that is the same, and I've got that is equal to that, and I know that that is equal to that. Okay. So I think we can show that these are congruent under the SAS rule, side, angle, side. Okay, so in order to prove it, all I need to do is say that angle G is equal to angle J, which was 36 degrees, and I can say that side GH is equal to side JK, which is equal to 9 centimeters, and I can say that side GI is equal to side JL, and that is equal to 7 centimeters. Okay, SAS, side angle side, so triangles are congruent. Okay, that's good enough. Okay, question 12. The cumulative frequency graph summarizes the annual salary P in thousands of pounds of 60 workers in the factory. Part A says use your graph to estimate the median annual salary. Okay, well, median means middle, and if you've got 60 people, then the middle one is roughly the 30th person. Strictly speaking, it's the 30.5th person, but out of 60 people, that is going to make not very much difference. So I'm just going to look across from 30. So from 30, read across to the graph. When I hit the graph, I'm going to change direction and look down, see where we end up. We end up there, which is 2 squares out of 5 squares between 20 and 30. Now, if there are 5 squares between 20 and 30, then each one of those squares is worth 2 then, isn't it? So 2 little divisions is going to be at 24. So the annual salary is going to be 24, but that scale is in thousands of pounds, so it's 24,000. Now they've already added thousands on the end, so I can just write 24 in here. 24,000. Okay, part B says complete this cumulative frequency table, so we need to work out how many are less than each of these values. So we just need to repeatedly read across from the graph then and fill this in. So less than 10, we need to read up from the graph and across. So up from 10 until you hit the curve and then across. I'll just show you the first one, what I'm doing. So I'm going up from 10 until I hit the graph, and then I'm changing direction and I'm going across, so a bit like the opposite of what I was just doing for the median, reading it the other way. So I'm going to end up there. So again, each little square is worth 2 here, so that's going to be, let's say that's 14. So I'm going to say that's 14 in there. Similarly, less than 20, reading up to the graph and across, I make that 26. From 30, just doing the same thing, that's 36. At 50, that is 50. And at 80, that's going to be everyone, isn't it? It's going to be at 60. Okay, part C says use the information in the cumulative frequency table to calculate an estimate of the mean annual salary. Okay, so I've brought down the cumulative frequencies that were in the first part. Okay, now if I want to do a estimate of the mean, I'm going to need some more columns really. So what I need to do here is work back from the cumulative frequency back to the frequency. Okay, now normally you work out cumulative frequency by adding the previous frequencies together. So if I'm working backwards, then I need to do the opposite of that, don't I? I need to subtract it from the one that's gone before. So 14, well, it's just going to be 14 in that first category. Now my next category is going to be 26 to subtract 14. It's going to leave me with 12. The next category is going to be 36 take away 26. It's going to be 10. The next category is 50 take away 36, which is 14. And then finally I've got my 60 take away 50 is equal to 10. Now you should find that when you add all those back up together again, it's going to give you 60. Okay, well, it should do. If it doesn't, you've gone wrong. Okay, so there's my frequencies worked out from the cumulative frequency, working backwards. Now usually when we do a estimated mean, we use the mid value of the range. So this one is going to end up being 0 to 10, so that's got a mid value of 5. This one here goes from 10 to 20, so it has a mid value of 15. This one goes from 20 to 30, so it has a mid value of 25. This one goes from 30 to 50, so it has a mid value of 40. This one goes from 50 to 80, so it has a mid value of 65. Okay, so once we've got those mid values, I need to then multiply it by the frequencies, don't I, to get FP. Just going to budge this over a bit so it fits a bit more on my page. Okay, so I need to multiply my mid value by my frequency to get my frequency times my mid value there. Okay, so 14 times 5, that comes out to be 70. Okay, 15 times 12, 15 times 12, that's 180. 25 times 10 is 250. 40 times 14, 40 times 14 comes out to be 560, and 65 times 10, that's 650. This is going to be sigma FP. This is sigma F. Sigma F is 60. Sigma FP then is going to be those numbers added together. So 560 plus 650 plus 250 plus 180 plus 70. So that all adds up to 1,710. Okay, so then my estimated mean is going to be sigma FP divided by sigma F, which is 1710 divided by 60, which is 28,500, or 28.5. That comes out to be 28.5. So then the as a salary, then that is £28,500. That was not a very nice question. Part D says, explain why your estimate of the median is more reliable than your estimate of the mean. The reason for this basically is that in the mean you have approximated each value to be at the midpoint of the range it happens to be in. So I've approximated all of my figures, haven't I? So for the mean, we used mid values as an approximate. Question 13a. A transport lorry consists of a cab and a trailer. The trailer has a volume of 90 cubic meters. Alfie makes a model of this lorry using a scale of 1 to 72. Work out the volume of the trailer in Alfie's model, given your answer in cubic centimeters. Okay, so if he makes a model using the scale of 1 to 72, that is a scale of their lengths. So ratio of lengths is 1 to 72, so the ratio of volumes is going to be 1 cubed to 72 cubed, which is going to be a rather big number. Well, 1 cubed isn't, that's just going to be 1. 72 cubed, what's that? Huge. That's going to be 373,248. Okay, now so the lorry then, volume of the lorry or the trailer, full trailer, is equal to 90 cubic meters. What's that in cubic centimeters? Now, in a meter, you have 1 meter is 100 centimeters, isn't it? So if you think about a cubic meter, which is 1 by 1 by 1, this is going to be 100 times 100 times 100 in centimeters, isn't it? Okay, so 100 times 100 by 100 is actually 1 million. So 1 cubic meter is the same thing as 1 million cubic centimeters. Okay, so 90 cubic meters is going to be 90 million cubic centimeters. Okay, so then the volume of the model trailer is going to be my 90 million cubic centimeters divided by that ratio we just found of 373,248, and that comes out to be 90 million divided by answer. I make that 241 and change. I'm going to round that off though, so I'm going to say that's 241 cubic centimeters. Okay, so work out the volume of the trailer in Alfie's model. Given your answer in cubic centimeters, it's 241. Part B says Alfie paints his model lorry. He has 8 colors available. He decides to paint the cab in one color and the trailer in a different color. He then wants to paint his name on the trailer. The name must be in a different color to the trailer. In how many different ways can Alfie paint his model lorry? Okay, so he's got the cab, he's got the trailer, and he's got his name upon the trailer, isn't he? Okay, so, and he's got 8 colors to paint it with. So for this first one, the cab, he's going to have 8 choices for his colors, isn't he? Okay, can use any one of those 8 colors. Okay, so then how many choices has he got for the trailer then? Well, the trailer, he's got all the colors he didn't use for the cab. So let's assume he picked color 1, then he's got color 2, 3, 4, 5, 6, 7, 8 left to choose from. So he's got 7 altogether. So whichever one he picked for the cab, he's got 7 other ones to pick for the trailer. Now, and then the name, it just says it needs to be a different color than the trailer. So again, he's going to have 7 colors available for the choice of the name. Okay, as long as it isn't the same color as the trailer, it's fine. So that means you've got 8 times 7 times 7 choices altogether. So the number of choices is these 3 values multiplied together. 8 times 7 times 7. 8 times 7 times 7, that comes out to 392. So he's got 392 choices. 392. Question 14. The diagram shows a circle with center OO and tangent at the point minus 12, 16. The tangent crosses the y-axis at a point 0, p. So the tangent, that isn't on the diagram, is it? So the tangent crosses the y-axis at the point 0, p. So it crosses the y-axis here. So that is the point P there then, isn't it? Where the tangent crosses the y-axis. Find the value of P. Now this is a circle. Let's just draw on the radius of this circle at the point where it touches that tangent. Okay, so that's going to be a right-angled triangle, isn't it? Okay, what we're trying to find P. Okay, so one way of thinking about it is we need to find the length of OP. It would be handy if we knew, let's call that point there T. Handy if we knew TP, because we could work out OT, and if we knew TP we could use Trigonometry Pythagoras, but it's not going to work here. I think what we're going to have to do is we're going to have to find the equation of that line of the tangent, which is not so difficult to do because we know a point on the line. We've got the point minus 12, 16. So if we can find the gradient of the tangent, we should be able to find its equation. Once we know its equation, we should be able to find the point where it passes through the y-axis. Okay, so how can we find the gradient of the tangent? Well, we know the tangent is at right angles to the radius drawn at the point of contact. So if we can work out the gradient of the radius, we should be able to then find the gradient of the tangent. So let's find the gradient of OT. Gradient of OT, which I'm going to call M1. Now, M1 is going to be change in y divided by change in x. Okay, so change in y is that value, and change in x is that value. Okay, if that's the point minus 12, 16, then that's going to be 16 then, and that's going to be 12. Okay, so it's going to be 16 over 12, except it's sloping downwards, so it's going to be negative. So it's going to be minus 16 over 12. Now 16 over 12 simplifies to 4/3. So the gradient of M1 is going to be minus 4/3. Now, because the tangent is at right angles to the gradient, then gradient of TP, which is our tangent, which I'm going to call M2, that's going to be minus 1 over M1, the negative reciprocal of the gradient of the radius. Okay, so in other words, we need to take the gradient of the radius, flip it over and negate it. So minus 4/3 is going to become 3/4 flipped over and sign changed. Okay, so that tells me then that the gradient of my tangent is 3/4. Now we are on a roll because we know the gradient of the tangent and we know a point where it passes through, so we're good to go. So we can say equation of TP is of form y is equal to the gradient 3/4 x plus c, where c is the y-intercept. Okay, now we don't know c yet, but we do know that it passes through the point minus 12, 16. So if we sub those two values into the equation, 16 equals 3/4 of minus 12 plus c, then that just leaves us c as the only thing that we don't know. Okay, what's 3/4 of minus 12? Minus 12 divided by 4 is minus 3 times 3 is minus 9, so that's 16 is equal to minus 9 plus c, so that gives me that c is equal to 16 plus 9 is 25. And actually that is the value we're looking for, isn't it? Okay, so equation is, just finishing this off, although we don't really need to, y is equal to 3/4 of x plus 25. Okay, so what is the value of p then? P is going to be the y-intercept. It's just going to be that value there, isn't it? The y-intercept is 25. When x is 0, 3/4 of 0 will disappear, y is be equal to 25. So then, what do we want to find the value of p? P is the height there, it's the y-coordinate, so p is just 25. P equals 25. Question 15a, calculate the length of DF in this triangle. Okay, well DF is this line here, that's the one we want to find. And what do we know? We know two sides and the included angle. We want to find the third side. So whenever we've got a non-right angle triangle and we are interested in sides and angles, we're talking about trigonometry in non-right angle triangles. It's either going to be the sine rule or the cosine rule. Now here we've got two sides and an included side angle, and we want the third side. Whenever you want to find three sides in a non-right angle triangle, we are talking about the cosine rule. That's the one we're going to need here. Okay. Now the general form of the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. Now I need to rewrite that in terms of my triangle here. So I've got D, F and G and not A, B and C, haven't I? So we normally label the sides the same letter, lowercase letter, as the opposite vertex. So if f is up there, look, then this is side f down here. If that's d there, then this is side d, and that's going to be angle g, and this is side g that we're trying to find. So actually we're trying to find g squared is equal to d squared plus f squared minus 2df cos g. Okay, just following the same pattern as the one we've got above. Okay, now just a matter of plugging those numbers in then, isn't it? D is 10 squared, f is 12 squared, minus 2 lots of 10 lots of 12 cos 30. Okay, well, I'm trying to do as much of this as possible before I reach for the calculator, just to make it a bit easier to type in. You could just type all that in. I tend not to. I tend to just do as what I can mentally. So 100 plus 144, which is 244, and then minus 2 times 10 times 12. 2 12s are 24, times 10 is 240, so 240 cos 30. So it doesn't take long to kind of simplify it down like that. Then it's a whole lot easier to type into the calculator. Okay, well actually cos 30 I know is root 3 over 2, but I'm going to be lazy because I've got my calculator. I'm going to type it in anyway. 244 minus 240 cos 30. Okay, that comes out to be 36.153. Just going to write that down as 36.1. G then is going to be the root of that. Okay, but I'm going to keep the full display and root my full display rather than the rounded off one. Root answer 6.01. Okay, I'm just going to round it off to 3 significant figures, 6.01 centimeters to 3 significant figures, 6.01. Okay, it's a good idea at this point just to imagine your length that you found in your triangle. Would 6.01 look reasonable over there with 12 and 10? Yeah, I think so. I don't think it would look that odd. You know, obviously if I'd got 36, it would look a very crazy triangle. So it's always good just try and imagine your final answer in the triangle and just see if it makes sense. Use your triangle to kind of error check as you go along. Yep, looks good. 6.01, I'm happy with that. Part B, calculate angle ACB in this triangle. Okay, so ACB, we want this angle down here. Let's call it theta. Okay, so normally when we're looking at non-right angle triangles, we're either using the cosine rule or we're using the sine rule. Now, cosine rule is about 3 sides. Either you've got 2 sides and you're finding a third one, or you've got all 3 sides given and you're finding an angle. We don't have all 3 sides here. We're not trying to find all 3 sides here. It's not the cosine rule that we need. Okay, but the sine rule is normally about opposite pairs. Okay, so normally we're looking for opposites. So here we've got an opposite pair, but the angle we want to find down here, it doesn't have an opposite over here that we can pair up with to use the sine rule. Okay, so how are we going to proceed? Because what we've actually got is this side here. So we could use that to find B. Once we've got B, we can just use the 3 angles inside a triangle add up to 180 to find C. So it kind of works. So we're not going to use the sine rule with C straight off. We're going to find B first and use the properties of the triangle to find C afterwards. Okay, so we're going to use the sine rule here. So the sine rule says A over sine A equals B over sine B equals C over sine C, or the other way up. I tend to write it down the way with the thing that I want to find on the top. Now I want to find an angle here. So I'm going to write sine A over A equals sine B over B equals sine C over C. So I'm writing it with the angles on the top because it's an angle I want to find. Now normally it's got a bit that we don't need, and here it's actually C. We're not going to use C, even though it's C we want to find. We're going to use the properties of the triangle to find it later. Okay, so we're going to use sine over a equals sine b over b. We're going to find b first. Okay, so let's sub in what we know. A is 63, so the sine of 63 over side A, which is 12.8, that is equal to the sine of B, which we're going to find, divided by the side B, which is 12.4. Okay, rearranging for sine B, really all I've got to do is move that over there, don't I? Okay, I'm going to flip it around at the same time. Right, sine B equals 12.4 sine 63 over 12.8. Okay, now remember it's B, we're going to find the angle, so we're going to have to use the inverse sine here, aren't we? So shift sine of 12.4 sine 63 divided by 12.8, close bracket. Comes out to be 59.67. I'm going to round that up to 59.7. So angle B then is 59.7. So then C is going to be 180 minus A, which is 63, plus B, which is 59.7. So what's that then? Add 60, take away 180. And that comes out to be 57.3 degrees. That's my answer, 57.3 degrees. Question 16. Show that x plus 9 over x squared minus 1 plus 4 over x plus 1 can be written in the form of a over x minus 1, where a is an integer. Okay, so let's start off with this bit over here and try and make it look like this. Okay, so we're going to take x plus 9 over x squared minus 1 plus 4 over x plus 1, and we're going to try and make it look like the other one. Okay, now the first thing I've spotted is this thing here. This is the difference of two squares. X squared is a square, 1 is a square. So I can rewrite that denominator on the left there as x plus 1, x minus 1. Okay? So you can see that then the two parts of the fraction now share part of a common denominator then, don't I? I've got an x plus 1 here, and I've also got one here. Okay, so I can put them over a single fraction. So I'm going to put them all over one fraction, x plus 1, x minus 1. Okay, now that denominator is the same as the denominator on my left, so that simply gives me x plus 9 over here. But on the other side, I would need to multiply 4 by x minus 1 to get 4x minus 1 over x plus 1, x minus 1. So on this side, I'm going to get 4x minus 1, like that. Okay, right, let's simplify what we've got in the numerator now then. So x plus 9 plus 4x minus 4 over x plus 1, x minus 1. So how many x's, how many numbers do we have? Got x and 4x, that gives me 5x. I've got 9, subtract 4, that gives me 5. Okay, so I've got 5x plus 5 over x plus 1, x minus 1. Can you spot what's going to happen yet? Okay, let's take the numerator. Got a common denominator in both terms. They're both multiples of 5, so let's factorize that 5 out. So 5 x plus 1 over x plus 1, x minus 1. Okay, now at this point you can probably spot that I've got a common factor top and bottom, which I can cancel out. So that x plus 1 cancels with that one, and that leaves me with 5 over x minus 1. Okay, so I've shown that that horrible looking sum can be kind of boiled down to 5 over x minus 1. So that's in the form of a over x minus 1 because our a value is our 5, isn't it? Everything else is the same. Okay, done. Question 17. Sketch the graph of y equals 3 to the power of x given the value of the y-intercept. Now, y equals 3 to the power of x is what we call an exponential function. They're super easy to draw because they all look the same. Okay, they all start hugging the y-axis like this and then increase exponentially like that. Okay, now no matter what the value is in front of the x, this point here is always going to be 1 because x is 0 at that point, and anything raised to the power of 0 is 1. So y equals 3 to the power of x, y equals 2 to the power of x, y equals 1,000,000 to the power of x. It's always going to pass through the y-axis at that same point. So pretty much any exponential function is going to look exactly the same. On this side, you need to make sure it's kind of heading towards the x-axis but never touching it, just getting closer and closer. And this one at the other end is increasing, increasing. Okay, that's it. 2 marks for that. Super easy. Question 18. The diagram shows a right-angled triangular prism ABCDEF. Okay. Now we're told that the length AD is 11, length CD is 10, and length CF is 6. Always check that these measurements they give you in the question are actually on the diagram, because sometimes they're not. This case they are, but obviously if they're not, then you're going to have a headache just looking at the diagram. You're never going to be able to solve it. Okay, but they're all here in this case. Calculate the volume of the prism. Now the volume of a prism is equal to the area of its uniform cross-section times the distance between them. So in order to work out this volume, we're going to need to know this cross-sectional area, and we're going to need to multiply it by this distance between the front and the back face. That's what we're going to need. Okay, so volume equals cross-sectional area times length or height, depends on which way around it is. Now in this case the cross section is it's a triangle, isn't it? So it's going to be a half base height, okay, which is 1/2 of the base, which is 10, times the height, which is 6. So we're finding area here, aren't we? So half of 6 is 3. 3 times 10 is 30. So that's 30 centimeters squared, the cross-sectional area. So I'm going to take that 30 and I'm going to multiply it by the length between the two faces, which is 11. 30 times 11, that's going to be 330, isn't it? 330 cubic centimeters. Okay. Now, part B says, use trigonometry to show that the angle FDC is 31 degrees. What is FDC? FDC. Okay, let's just clear this up a little bit. So FDC, this one here, isn't it? We want to show that it's 31 degrees. Okay, so we can't write 31 in there. I need to go and find it. Okay, I want to find it and then find out that, oh yeah, it's 31. How can I find that angle there? Okay, well, can we use trigonometry? If this angle is theta, then I've got the opposite and the adjacent in a right angle triangle, so I can just use straightforward trigonometry here, can't I? This is the opposite, this is the adjacent, this is the hypotenuse. So I've got the opposite, I've got the adjacent, I don't have the hypotenuse, don't want the hypotenuse. So which ratio do I need? Well, using our handy mnemonic, SOHCAHTOA, the one that we want is the TOA part, isn't it? Okay, which tells me that tan theta is equal to the opposite over the adjacent. Okay, now that is equal to the opposite, which is 6, over the adjacent, which is 10. So then my theta angle then is going to be the inverse tangent of 6/10. Tap that into the calculator. Hopefully it's the right answer. So shift 10, 6 divided by 10. Oh, look at that, it's 31. That's equal to 31. We did it. Part C says calculate the exact length of AF. The exact length. Okay, so how can we find the exact length of AF? Well, you could say, I mean, this is a right-angled triangle, isn't it? It's basically a cuboid which has been cut in half, isn't it? Can you see that? So if you had like the equivalent cuboid, which had size 11, 10 and 6, then basically you've taken that cuboid and you've sliced it down here, haven't you? Cutting it in half. Okay, and that gives you your wedge. Okay, now what we're trying to find is the distance from that point up to that point then, isn't it? It's that long diagonal. It's this long diagonal going through the middle of the cuboid. Now there's a quick way of working out this longest diagonal. It's a bit like an extension of Pythagoras Theorem, and it goes kind of the length of that diagonal squared is equal to x squared plus y squared plus z squared, all square rooted, which is basically the three sides of your cuboid squared, added up, and then square rooted. Well, that's just, I had too many squares there. So it's d, the length of the diagonal is going to be the square root of x squared plus y squared plus z squared. Okay, so that is going to be 11 squared plus 10 squared plus 6 squared, all square rooted. 11 squared is 121, 10 squared is 100, 6 squared is 36. So adding those up, 121, 221, 251, 257. So it's root 257. Okay, and it's asked me for the exact length, so I'm just going to leave it as a surd. Question 19. The graph shows the distance travelled by a particle over 8 seconds. And we've been asked to estimate the speed of the particle at 5 seconds. Now this is a distance time graph, isn't it? So the speed is the gradient of the graph. Okay, so basically what we need to do is we need to find the gradient of the graph at a time t is equal to 5. So at this point here, how steep is this graph at this point? Okay, well, clearly it's a curve, not a line. So to find the gradient of a curve like this, what we do is we draw on the tangent at that point by just kind of pushing our ruler up against the curve, so it kind of just touches, and you've kind of got the same amount of space either side here. Okay, so it's not an exact science, but you kind of just do it by eye as best you can and draw on that line. Okay, so there's my one there. And then what we need to do now is just find the gradient of our drawn line. So how do we do that? Well, we just look at change in y and change in x then, don't we? So change in y is that length there. That's quite easy to read. That's my numbers on here have gone a bit wonky. So that's 1, 2, 3 units, isn't it? So that's got a distance of 3. And then along here, I've got 1, 2 about 2.4 seconds this way. Okay, so then the speed equals the gradient, which is equal to change in y 3 divided by change in x 2.4. What does that come out to be? 3 divided by 2.4, 5/4. That's 1.25. 1.25 watt. Time was in seconds. So and distance was in meters. I divided meters by seconds. I've got meters per second then, haven't I? Okay, so that's 1.25 meters per second. So now don't worry if your speed is a little bit more, a little bit less than this. It's really going to depend on how you've drawn your tangent on. Okay, so you'll definitely get the same height as me as 3, but your length along here is going to depend on how you drew your tangent. So there's going to be a bit of variation in the answer, but as long as you use your distance in your calculation, then you're going to get the answer right. Okay, and we're done. Good job. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.